Here we go, folks. Another round of exciting study guide chemistry fun. Okay, stop rolling your eyes at me. Question number 1. In chemistry, what is meant by the term mole? Not the furry little thing on your aunt's face, no. And of course, what's the importance of this guy? Well, it's a way to package extremely small, tiny little things. But because they're so tiny, I need a gargantuan number like the mole to package it. Now, make sure you know the value of a mole and when National Mole Day is and when it starts and when it ends and how to sing the mole song. Oh, and I digress. I apologize. The importance of the mole concept is that allows us to use numbers that are reasonable in a lab. See, I know for a fact that 1 proton is equal to 1.66 times 10 to the negative 24th grams. I can't weigh that in a lab. That's just silly. So I'm not going to use that. No, but this many grams of carbon is equal to 1 mole, and I can weigh that in even the most basic chemistry classrooms. Well, it's a good idea to make a plan. Always a good idea to make a plan, especially as these problems get more complex. Well, we've been given grams of carbon, and I gotta get to moles. Well, to go from grams to moles, where do you find that conversion? Well, if you said the periodic table, you are correct. So we're going to start with 24.02 grams of carbon. Don't drop units, please. According to the periodic table, for every 12.01 grams of carbon, we have 1 mole of carbon. Well, the grams cancel. I'm left with moles of carbon, which is what I want, and I don't even think I need a calculator for this. Nah, I don't need a calculator. We're going to do 2.00, ooh, look at that, 4 sig figs, 0 moles of carbon. That's all that problem wanted. Oh, if only things were that easy, right? Look at this, we're on number 3 already. Really, if you haven't worked through the study guide yet, would you please stop or pause the video and at least try these problems before I do them to see how you're doing? Okay, enough of the soapbox. Given grams, we got to get to atoms. How do you go from grams to atoms? You can't. Well, not directly. You actually have to go from grams to moles to atoms. The conversion between grams to moles is found on the periodic table. And from moles to atoms, yeah, it's that dude's Avogadro's number. Well, let's start with what's given. And 500, totally ignoring sig figs here, grams. I know, I even recorded my saying that. Shocking. Grams is here, so bring it down. Grams of titanium for 1, always 1 mole per gram. 1 mole per gram. Always. Now, looking on the handy-dandy periodic tables, searching for titanium, I should really get new glasses because it's not popping out here. Oh, look at that. It's right in front of my face. 47.88 grams of titanium. Well, that got rid of grams of titanium, so am I done? No, because I need atoms. Okay, so moles comes down here. Gotta chase that unit down. Moles of titanium. And, oh yeah, atoms. To Avogadro's number of atoms. Now, always it's to 1 mole. Always. And you should know Avogadro's number, 6.022 times 10 to the 23rd. Now we can use the calculator. So 500 times 6.022 times 10 to the 23rd divided by 47.88. So that gives a final answer of, well, Yeah, 6 point, and I said because I went back and double checked those sig figs. I need 4 sig figs, so 6.289 times 10 to the 24th atoms of titanium. Now please make sure you enter the times 10 to the 24th. One thing I saw some students do was they wanted to write E24. No, don't do it. Just because your calculator does it, don't do that. And please make sure you're reading the calculator carefully and that you notice it really does say times 10 to the 24th. Okay, well, that's all I got on this problem. Okay, well, now the problems are going to start to get just a little more complicated. Of course they are. Well, okay, so mass in milligrams. What is the mass? Definitely after grams. And we're starting with atoms. Atoms. But then it's got to be in milligrams. Ah, snap. So how do we go from atoms to milligrams? Well, I'm pretty sure we can go from atoms to moles, and then from moles to grams, and grams to milligrams. Oh, that should be no problems. So 3.54 times 10 to the 54th atoms of calcium. Okay, ooh, that's a wonderfully unstraight line. Okay. Atoms goes down here, and according to the plan, we have to go from atoms of calcium to moles of calcium. And we know that Avogadro's number is always equal to 1 mole, and that got rid of atoms. And now we're through this part. Now we have to go from moles to grams. Well, chase the moles down, moles of calcium to grams. Where do we find the conversion? On the periodic table. So we have 40.08 grams of calcium to 1 mole of calcium, always to 1 mole. Drop the moles of calcium out of there. And now we have to go from grams to milligrams. Well, remember a long time ago when we did King Henry died by drinking chocolate milk? Okay, good. Well, grams is bigger, so that gets the 1. The system's based on 10. And between those, there's 3 steps. Now we're ready to use the calculator. Okay, so 3.54 times 10 to the 54th times 40.08 times 10 to the 3rd divided by 6.022 times 10 to the 23rd, and we end up with, make sure you have 3 sig figs. Well, that's a fail. How about this? 2.36 times 10 to the 35th milligrams of calcium. See, that wasn't too bad. Calculate the percent by mass of each of the following elements in caffeine. Oh, my favorite molecule. What do we need to do first to solve this problem? Well, if you said the first thing we need to do is find the molar mass of caffeine, you are correct. So let's see, 8 times 12.01 plus 10 times 1.008 plus 4 times 14.01 plus 32. Yeah, I did 16 times 2 in my head, sorry. So you should have ended up with a molar mass of 194.2 grams per mole. Now, percent by mass, that means we're always going to take the part, divide it by the whole, and multiply it by 100. The part we're interested in for each one, the part that's carbon or hydrogen or nitrogen or oxygen over the whole thing, which is the molar mass. So let's take the part that's carbon. 8 times 12.01 divided by 194.2. Oops, better times that by 100. That's a time sign. Really, it is, yeah. So 8 times 12.01, divide that by 194.2. We end up with a percentage of, and you can round these to the ones place, I'm okay with that. So 50% carbon. Now we can do hydrogen. 10 times 1.008 divided by 194.2 times 100. Okay, punch that into the calculator. Okay, 5% hydrogen. Now for the nitrogen. 14.01 multiplied by 4 divided by 194.2 times 100. %. Now you could do that again for the oxygen, 32 divided by 194.2, that would have been fine, or you can add these three up and subtract that from 100. So I'm going to do that. I'm going to add up all of these, so 55 plus 29, and I'm going to take that number from 100. So I now know it is 16% oxygen. And as a really good check, double check to make sure that all four of these numbers add up to 100. And in this case, they do. So we're done. All right, take a minute and read through this problem. Well, the first thing that I notice is percentages. And percentages, you can't really use percentages, but if I assume I have 100 grams of the substance, because it doesn't matter how much you have, the percentages aren't going to change. Do you remember the cookie example? If you can tell me about the cookie example, I'll make that worth some extra points. Anyway, the point is, this, I can just change to grams, because this percentage times 100 grams is that many grams. I love the number 100. However, notice this substance contains three, carbon, hydrogen, and oxygen. Just as a side note, those are called hydrocarbons. Hydrocarbonates, hydrogen, carbons, and if it ends in ate, it has an oxygen. So we're dealing with a hydrocarbonate, but they didn't give me the percentage of oxygen. Snap. Well, the nice thing with percentages, it's got to max out at 100. So if I take 100 and I minus it from the sum of these other two, plus 8.16, you're going to get the percentage of oxygen. So I'm going to go ahead and do that. 100 minus 48.64 plus 8.16. And that is then 43.2% oxygen. But since we have 100 grams, I'm going to go ahead and call it grams of oxygen. Now you need to convert that to moles of oxygen. So I'm going to take that number and divide it by 16. And you end up with 2.7 moles of oxygen. Now let's do the carbon. 48.64 grams of carbon. I trust you can get to moles on your own. So we end up with 4.05 moles. I'm paying attention to sig figs here, of carbon. Hydrogen, 8.16 grams of hydrogen, and again, I trust you can get to moles. And that gives me 8.10 moles of hydrogen. Now what? Well, if you said divide each by the smallest, you are right. So I'm going to divide all three of these, and that way I can get my subscripts. Well, this number divided by itself is 1, so I have 1 oxygen. 4.05 divided by 2.7, 1.5. Carbons. 8.1 divided by 2.7. And that gives me 3 hydrogens. Well, I can't have a half. Subscripts can't be halves, they have to be integers. So I'm going to multiply each one of these by 2 to get rid of that stupid decimal place. So formula, we end up with, and I'm going to do carbon first because carbon's there. So C3, now I'm going to do the hydrogen next because that's what's listed next and that's the way it should be. 6, and then oxygen 2. Now, if you don't put these in this order, I'm not going to dock you, but you should know that generally it's in the order that it's listed, and hydrocarbonates always come out C, H, and O, even though they're called hydrocarbonates. Yeah, maybe we should have called them carbon hydrogenates. I don't know. Anyway, that's what we have. And our final answer, we are done with this problem. Okay, take a minute and read through the problem. And to do this, we're going to need the empirical formula from the problem above. So there it is. And the other thing you should know is evidently I have a typo here. Oops. This should have been 370. Whoop, whoop. Warning, 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 alert. Okay, so, well, to solve this problem, remember the relationship between the molecular formula and the empirical formula's masses. If I take the molar mass of the molecular formula and I divide it by the molar mass of the empirical formula, I'm going to get what I call the multiplier. Well, I have this number. How am I going to get this number? Oh, did you say add those up? Well, if you add them all together, you get, pause the video, give it a try. I get 74. When I divide those, we get 5. So what am I going to do with that number? Ooh, did you say multiply each one of these subscripts by 5? Well done. So C15, H30, O10. I have no idea what substance that is, but since I made the problem up, I might have made an error in the percentages, but we're just going to run with it, and that's good to go. Good luck on the test, and have a great day.